Ida.
Hi, my name is Jason Bisarnes.
Hi, I'm Alison Gomez.
Hi, I'm G. Arellano.
Hi, I'm Daisy Mian Arsinachan.
My name is Harvey John Hilado.
I'm Gemma Menyosa.
My name is Lovely Joyce Estabi Isa.
Hi, I am Joanna Olivia Artisa.
Now that we're done with the introduction, we will now discuss about our chosen topic, which is electromagnetic waves overview.
To understand this topic, we need to know what is an electromagnetic wave. Electromagnetic waves or EM waves are waves that are created as a result of vibration between an electric field and a magnetic field. In other words, EM waves are composed of oscillating magnetic and electric field.
As we stated earlier, electromagnetic waves are formed when an electric field comes in contact with a magnetic field. They are hence known as electromagnetic waves. The electric field and magnetic field of an electromagnetic wave are perpendicular at right angles to each other. They are also perpendicular to the direction of the EM wave.
Electromagnetic waves are transverse wave. That means the electric and magnetic field change in a plane that is perpendicular to the direction of propagation of the wave.
Electromagnetic waves are created by the movement of an electrically charged particles, and they are characterized by their frequency and wavelength. The frequency of an electromagnetic wave refers to the number of times the wave oscillates or vibrates in a second, and it is measured in hertz. The wavelength of an electromagnetic wave is the distance between two successive peaks of the wave, and it is measured in meters.
Electromagnetic waves have a number of properties that make them unique and useful in various applications. Some of the key properties of electromagnetic waves are:
They do not require a medium to travel through, unlike sound waves, which need a solid, liquid, or gas to transmit energy. This means that electromagnetic waves can travel through a vacuum, such as the space between planets.
They can travel at very high speeds, approximately the speed of light, which is about 300 million meters per second. In a vacuum,
They can be absorbed, reflected, or transmitted through various materials, depending on the property of the materials and the frequency of the electromagnetic wave.
They can be polarized, which means that the direction of the electric field component of the wave is aligned in a particular direction.
They can be created and detected using various types of antennas, which are devices that are designed to transmit or receive electromagnetic waves.
They can be harmful to living organisms in high doses, such as from prolonged exposure in high-energy electromagnetic radiation, such as X-rays and gamma rays.
we now know the electromagnetic waves and its properties, so let's talk about some of the numerous common applications that electromagnetic waves have in our day-to-day lives.
Electromagnetic waves have a vast range of practical everyday applications that include such diverse uses as communication by cell phone and radio, broadcasting, Wi-Fi, cooking, vision, medical imaging, and treating cancer.
Since most of us use technology in our daily lives, these examples are quite helpful to everyone and not only for technology but can also help in medicines like the magnetic resonance imaging or MRI. Whether it is technology, medical field, or even about food, this just proves that electromagnetic waves help us with many things.
EM waves are composed of oscillating magnetic and electro fields.
The electric and magnetic fields change, oscillate the plane that is perpendicular to the direction of propagation of the wave.
Electromagnetic waves do not require a medium to travel.
In a vacuum, electromagnetic waves travel at the speed of 3 times 10 to the 8 power meter per second.
Or to transmit energy, such as an
We now know the